Okay, origin and evolution of Earth crust. It is not same as the origin of Earth, which we've seen already, like nebula theory, tidal hypothesis, and Big Bang theory. This is the origin of the Earth's crust. So we know that Earth's crust is differentiated into oceanic crust and continental crust. This is basaltic, this is granitic and andesitic, this is basic, this is acidic and intermediate. This has high density of 3 to 3.5, this has lower density of 2 to 2.5. It is mafic and this is felsic and intermediate, and this is thin and only 1 to 3 kilometers. This is thick 60 to 80 kilometers. So origin of the earth crust, it is related to the origin of earth itself, but around 3.8 billion years ago, the primordial crust, which was the initial crust, was much different. So this initial crust was formed due to the cooling of the outer nebular gaseous layer into the solid. So it cooled and solidified. So since this was happening just then, it was very brittle and unstable. So we can see it is very thin and very it was subjected to two things. First one is repeated fractures due to meteorites. Since there was no atmosphere, the impact was very strong, and because the crust was very thin, it used to fracture here and there, and because of that, volcanic eruptions used to happen there. So this would create the mantle convection cells, which would circulate the lava through the surface, and formation of the igneous rocks. So as we've seen, the magmatic eruptions and disruptions, they set up the mantle convection cells, and this creates the volcanic outflows. So this will create forced volcanic eruptions, and first igneous rocks were formed, but later these were pulled back into the mantle because of repeat, and led to the repeated partial melting. So initially the igneous rocks are formed, again due to the convection currents they are pulled back into the mantle, and new igneous rocks are formed, and this process continuously goes on. This keeps on repeating, so repeated partial melting happens. So initially the very ultramafic rocks will turn into very ultramafic, then later into ultramafic, and finally the initial ocean crust was formed when the ultramafic peridotite and diorite, they turned into basalt. Thus initial first ocean crust was formed. Later this ocean crust is also subjected to repeated subduction partial melting. Thus initial continental crust was formed from basalt, andesite and granite. So but these continents are very small and called as the microcontinents. So this is how crustal differentiation happened, how crustal continental crust emerged from the oceanic crust. So we can say that oceans are more fundamental because they can get subducted and get destroyed. And also oceans are more fundamental because they are the ones that led to the continental formation. But once these microcontinents are formed, they can drift, and they can drift on the earth's surface, and they resist subduction because continents are very light and buoyant, so they won't subduct. So we can say that continents are permanent while oceans are more fundamental. So they collide, deform, but they won't subduct into mantle and get destroyed. So ocean continents are permanent. Today we know that oceans they get destroyed and recycled, and continents they keep on growing and adding on the surface. Was established by Harry Hess, who did the ocean mapping, and he established that nowhere the ocean was older than Mesozoic times. So all of this is related to the microplate tectonics theory. The formation of microcontinents was explained by this. So microcontinents, with time they collide and they fuse and they form the supercontinents. Later supercontinents again they break up, they collide and fuse and form newer and larger supercontinents. So in the Earth's geological history, we have known such supercontinents. More than 2.5 billion years ago, we had Valbara, Ur, Kenorland, Atlantic, and Arctica. And recently, 1.9 billion years ago, we have Nuna, Pannotia, Rodinia, and recently in the Wegness Carboniferous time, we have the Pangaea, which is a recent supercontinent, which later broke up. So Wilson cycle, it wants to explain how the origin and evolution of Earth crust. So it is a continuous repeating cycle, starting with the supercontinent split and the ocean formation, then the ocean floor subduction and the recollision of continent and formation of the bigger supercontinent, and again the process continues. So this is a repeating cycle. So Wilson cycle, we have 10 stages. First stage is the embryo stage, where there is a microcontinent or small continent, and we have the diverging limbs. So second stage is stage of stretching, where the continent stretches, and next we have rifting stage, the stretch further thins and the rift valley is formed. Next we have nascent oceanic stage, the rift valley turns into the nascent ocean with basaltic floors forming. Next we have proper ocean with more formation. Next we have stage of continental erosion and sediments depositing at the edges of the continents. And next we have, due to the weight of the subduction weight of the sediments, the ocean floor starts subducting. And next, due to the subducting ocean floor, we have the accretionary prism forming, and this subducts into here, and the resultant volcanism on the melange formation and anti-step fold mountains are formed here. Next, this entire ocean floor is subducted. So this is subducted and the volcanic eruptions come over here. Next we have the because the entire ocean floor is destroyed, the continents come together and they collide and then form the Himalayan type mountains. So this is a supercontinent formed, and again the process repeats. The divergent limbs come here and the entire process repeats again. Next we have the geomagnetism. It is an important physical property of Earth because Earth behaves like a dipole magnet. So Earth's magnetism was first discovered by William Gilbert in 1600s, where he found magnetic rocks like lodestone. Next, some facts about geomagnetism. We have magnetosphere up to 60,000 to 90,000 kilometers above Earth's surface. Second, in the magnetic south pole is near the geographic north, and the geographic south near the geographic south we have the magnetic north pole. But for convenience sake, we call them magnetic north and magnetic south in the reverse order. Next, we have the angle of declination, which is the angle made by the magnetic axis with the geographical axis. This varies. This is not constant in reality, but we consider it constant for our convenience because the poles keep shifting here and there. Next, near the poles, the magnetic lines converge and they interact with the ions in the atmosphere. Therefore, there we can see the brilliant display of lights in form of aurora borealis in the northern hemisphere and aurora australis in the southern hemisphere after the Antarctic Circle and the Arctic Circle. Next, the magnetic field of the Earth undergoes three variations of fluctuations in terms of location, strength, and polarity. The location shifts, but they do not migrate great continental distance. They migrate just here and there. Next, we have the strength of poles. They vary. They can weaken or strengthen. Magnetic poles they can reverse, but this reversal is not due to the south pole going all the way here. Rather, the strength changes from +8 slowly to 0 and then to -6. So this is how polarity reverses. Next, we have the magnetic dip. It is the angle the magnetic lines of force they make with the horizontal surface. It can be measured using the magnetic needle, and the angle it makes with the horizontal surface is the magnetic dip. So at the magnetic equator and magnetic poles, it will be 0 degrees and 90 degrees. But since the geographical north and the magnetic south are very close together, the angle both would be same for our convenience only. So this is only a coincidence. Next, how did the Earth's magnetic field originate? So first theory was given by William Gilbert himself, who gave the embedded magnet bar magnet that Earth has a bar magnet inside it. But it is wrong because due to the high temperatures inside the Earth's interior, the magnetic material would melt away. Next, we have the single dipole next we have the theory that magnetic rocks inside the Earth like magnetite and they create the magnetism, but the orientation of such rocks is very different, and but Earth behaves like a single dipole magnet. So this is also wrong and this is also wrong. Now the most accepted and recent theory is that it is geomagnetism because of the core behavior, which has fluidic plasma outer core and solid inner core. So inner core is solid and it has iron rich, and we have the electron spinning in the outer plasma core, and because of this it creates a moving electric field around the iron rich inner core, and thus it becomes a self-exciting electromagnet, and thus the Earth's geomagnetism can be explained using this principle.